Today we're going to start a brand new unit. This entire unit is about squares and square roots. Today we're going to focus on calculator use in squares and square roots. And this is the note packet that you'll need for today's notes. So let's start with a square. If you take any number and raise it to the second power, you will produce what's called a square. So here's an example. This is 3 raised to the second power. Remember, this is not 3 times 2. What this really means is a number times itself. 3 times 3 creates 9. 9 is classified as a square number. If you write a square root radical, like you see here, the number that's contained underneath the radical symbol is called a radicand. If you want to refer to something as a square root radical, you're referring to both the square root radical symbol and the radicand as an entire term. When you take any number and you write it as a product of two equal factors, so it could be 2 times 2 or 15 times 15, we're going to produce a perfect square. So here's an example. 6 times 6 produces 36, and 36 is classified as a perfect square. What's nice about perfect squares is that if you want to work backward and square root them, you're going to get a rational number. That means it'll be something that's either a whole number or an integer or a fraction or maybe a terminating decimal. So 49 I recognize as a perfect square. Usually I have memorized all the way up from 1 through 15's perfect squares. It is helpful so that you don't have to mess with the calculator, you just recall them from memory. So if I take the square root of 49, it's possible that I have two identical factors of positive 7 or negative 7. So if you think about that, negative 7 times negative 7 would produce positive 49. 169 is a perfect square, and if I square root, my factors are both positive and negative 13. 400 is a perfect square. This is not in the set from 1 to 15, but yet most of us will recognize that. And the square root are both positive and negative 20. Typically, your calculator or your iPad will only show you a positive value, so you have to remember that there is a negative root there. We can also square root a fraction. Hopefully you notice that both the numerator and the denominator are perfect squares. So when I square root, it's possible to have both positive 2/3 and negative 2/3. So this will work for any non-negative number. That means you have to have a positive number underneath the square root radical. If you look at the example on the left, if I square root the number 7 and then square it, what I'm doing is performing inverse operations. And basically those operations will wipe each other out. And the result of that is just 7. It's the radicand all by itself. So generically speaking, for the example on the right, if you square root any number a that's positive and then square it, you'll get the value of a back. So when you recognize something like this, you don't even have to do any calculations. It's simply whatever value the radicand takes. So every positive number is going to have two square roots, and we've talked about this. One of them is a positive root, and we call this the principal square root. Most oftentimes, we're looking for the positive value. But the other root is a negative. So keep that in mind when you're coming up with solutions. There could be both a positive and a negative root. One thing I want to caution you on, we do not take the square roots of negative numbers. As far as we know, it doesn't exist in the set of real numbers. That's the number set that we're used to working with. If you move on to Algebra 2, you'll talk about the imaginary number system, and then it would be okay to use a negative square root. But right now, if you have a negative square root, either it's not going to be able to be calculated, or you have some kind of mistake in your problem. I just want to show you on the iPad here, when you're working with square roots, this symbol here on the left in the circle is typically the one that you want, and you'll have to select the square root first. If they change the index, and we're going to talk about that in a second, you're going to want to use this value. You'll see a little box sitting in front of the square root radical that allows you to change the index. So if you want to take other roots than square roots, the index will tell you how many roots that you'll need, or the number of identical factors. When no index appears, and that's what we're used to, we understand that we're looking for 2 identical factors. So the index is 2, even though it won't be written. So here's an example. The square root of 64, I'm looking for 2 identical factors that will create 64. You can see right here in front in this little elbow, there is nothing there. That tells me that the index is 2. So the values are positive or negative 8. You can see right here, I said that the index is 2, and that means I'm looking for 2 identical roots. You can see in the next example, though, I have changed the index, and it's sitting kind of in that elbow. This tells me I want 3 identical roots that would all multiply to create 27. If you want to pause the video for a minute, you can activate this key on your iPad. You're going to put the index in first, and then the 27. So the index will be 3 identical factors or roots, and the answer is also 3. 3 times 3 times 3 will produce 27. In this last example, we're looking for 5 identical roots that will multiply to 32. And the index is 5, but the answer is 2. So we would multiply 2 by itself 5 times. What you should note with the cube root of 27 and the 5th root of 32, in both cases, we did not have a positive and a negative root. There's only a positive root because the only way to produce a positive radicand, 27 and 32, would be to have all positive values. If you want to take the square root of a number that is not a perfect square, and there are an infinite number of these, we can write a decimal approximation. This is an estimate, and it will depend on where they want you to round this answer to. Sometimes it's the tenths or the hundredths or even the thousandths, but it's not an exact answer. So here on the number line, there's always a spot for a square root to be placed on the number line. It's just not an exact answer. So we're going to do that. If I have the square root of 5, I can put that into the calculator or the iPad. Now your iPad's going to return square root of 5, so you might have to hold down the enter button and slide your finger up to the equivalence. But this value, put this on here, equals 2.236. Oh, that doesn't look good. So what that tells me is that the square root of 5 is located somewhere in here between 2 and 3. So 2 and 3 would be the consecutive numbers that come before and after. Let's try another one. We have the square root of 67. When I enter this into my iPad, I have a value that is 8.185. So I know that the square root of 67 falls somewhere between 8 and 9, but I think it's a little bit closer to 8, so it's right about here. And one more example, the square root of 111 is slightly larger than 10. So the iPad tells me that it's 10.5357. And I'm going to round this off to 536. So I know that the square root of 111 is somewhere in here. So we can come up with a decimal approximation. We can also locate a position for this square root radical on the number line. Here's a few examples just to finish out the lesson. Watch the wording. When they ask for the square, they're asking you to do 4 to the second power, which means this is 16. In example number 2, it says 4 squared. It's the same as number 1. This is 16. In number 3, they're asking for the square root of 4. They want you to square root it. 4 is a perfect square. So this tells me that I would have both positive and negative 2. For number 4, we know that this is 16. And number 5, square root of 16 is perfect square, so we're going to have positive and negative 4. For number 6, it says estimate each square root by naming the 2 consecutive whole numbers between which the square root is located. So again, you can put this into your iPad. The square root of 19 is going to be 4. It's 3589. So I'm going to round it off to 36. What they really want to know is that this falls between 4 and 5. That's supposed to be an and sign. For number 7, the square root of 63. On the iPad, it's a little over 7. Actually, it's closer to 8. This is 937. So that tells me that the square root of 63 falls between 7 and 8. For number 8, the square root of 48 is 6.9282. So I know that this number falls between 6 and 7. And finally, the square root of 80 is equal to 8.944. So that tells me that this is between 8 and 9. It is possible that the square root radicals will get larger, and then the numbers that they'll fall between will be bigger as well. All right, in your packet, homework number 109 will start like this. It's one-sided. What I've done is I've tried to set it up so that the backside is blank, or it has the phrase, "This page was left blank." If you need to show work, please put the work on the back, and then when you submit your assignment, make sure you take pictures of both sides. Remember, I sent you instructions on how to convert to a PDF. Please, please, please take all of your pictures and convert them to a PDF so that it's in one assignment. That'll make my life much easier because I'm being overwhelmed with homework assignments. So, if you need me, please don't be afraid to call me. You can text me on my cell, you can call my home number, or you can send me an email and ask questions. Please submit your assignment as soon as you have finished. Have a great day.